Hello, this is going to be a quick video on how to analyze trusses using the sections method. Okay, so when we're using the section method, we need to first think about where we're going to make this cut. And that depends on what you're trying to find. So let's say, for example, I'm really interested in finding member C. I'm going to cut through member C. And I want you to always try to be cutting through three members. So I'm going to cut it here. I'm cutting through B, C, and D. Okay. Now to redraw that, hello. Hello. This is going to be a quick video on how to use the section method to analyze trusses. Okay, so when we're starting with the section method, we first have to decide where to make a cut. Well, let's say, for example, I was interested in finding members B, C, and D. To do that, I'm going to create a cut on this blue line right halfway down through each of them. So I'm going to redraw it. I'm going to say point one halfway. Say there's point two way. B, B, C, D. All right, and just to keep it straight, I'm highlighting these members which are being cut. Okay, and now what I want to do is I want to think about the sum of the moments to solve this. And when you're thinking about where to rotate around for the sum of the moments, I suggest that you always try to start with points that aren't going to involve the diagonal members because it gets a little bit trickier that way. So I need to find a point which doesn't have a moment including the diagonal members. Well, I know that point two is going to work for that because the diagonal member C goes directly into point two. So if there's no distance away from point two, then the moment for C is going to be zero around point two. So that's good. That gets rid of my diagonal member, and that's going to help me out. So I can say sum of the moments is around point two is equal to zero. I'm going to say that counterclockwise moments are positive. So now I need to think about what is going to go into this. Well, rotating around joint 2, should I include D? No, because D is going right into point 2, so the distance would be 0 and the moment would be 0. Should I include member C? No, same reason. It's going it's going into joint 2, so there's 0 distance, 0 moment. Should I use RA? No, same reason. It's going into joint 2. I use the 2K. No, same reason. Even though it looks like it's farther away, if you were to extend this arrow, it would point right at a joint 2. So the moment is 0. Should I use a member A? No. You never use the members for the moments unless they're being cut. Should I use member B? Yes, because it isn't pointing at joint 2 and it is being cut. So I can say is equal to B, and then I need to multiply it times the distance that B is away from joint 2 perpendicularly. So that is going to be the same as the length of A. And we know from our problem that that's going to be 5 feet. B times 5 feet. And that is the only force that I can include in this moment equation. So if that's the case, then I know that B is going to be equaling 0 because there's nothing to counteract against it. So B is equal to 0. Next, let's think about getting C and D. Well, we already did the sum of the moments around 1, and I think we should still try to avoid the diagonal member until we know what D is first. So to get D, I can't use joint 2 because D is uh, going right at it. So I'm going to come into the imaginary zone. I'm just going to continue my members in the imaginary zone, the matrix. And in the matrix, there's joint 3 and joint 4. So I can use these as places to get a moment around. So I'm going to choose to use joint 3 because I don't have to worry about this diagonal member because it's pointed right at joint 3. So it's just going to be 0. I can say sum of the moments around joint 3 equal to 0. And let's see, what should I use? Well, should I use C? No, I should not use C because it's going right at joint 3 and it's going to be 0. Should I use B? No, same reason. Should I use the 2 kips? Yes, I should. So I'm going to say is equal to 2 kips times, I need to know the distance from joint 3 to the 2 kips perpendicularly. And that's going to be 5 feet. You can see in the problem, that's the distance from joints 1 to 3. So times 5 feet. And let's see, should that be positive or negative? Well, the 2 kips is going down and it would go like this. So it would create a moment that is counterclockwise. So it's going to be positive because that's what I stated in my equation. Next, should I use member A in the moment? No, because it's not being cut. Should I use RA? Yes, I should. Let's say plus RA times. And then I need to know the distance that RA is from joint 3 perpendicularly. And even though it looks like it's further away, this is also going to be 5 feet. Because if I were to extend RA, it would be in line with this 2 kips. So it's going to be the same distance as the 2 kips was away. So RA times 5 feet. But wait a second. RA is going in a different direction than the 2 kips. It would be creating a moment that is clockwise. So that means that this RA needs to be negative. Okay, and then finally, there's D, and I am going to use D. So let's see, because it's being cut and because the moment isn't going to be 0 because there's a distance from joint 3. So I'm going to say plus D. Oops. This is going to be the distance from D to joint 3 perpendicularly is going to be the same as the distance from joints 1 to 2, which is 5 feet in the problem. So I can say D times 5 feet. And I don't know which way D is going to go, but I'm just going to assume for now that it is positive. That's my assumption, which would mean that it's going in a counterclockwise direction. So now I can start solving this. Now I can say, well, 0 is equal to 10 kip feet plus negative, we know RA is 3.33 kips feet plus D times 5 feet. 0 is equal to 10K minus 3.335. That's minus 16.65 K feet plus D times feet. 0 is equal to negative 6.65 K feet plus D times 5 feet plus 6.65 plus 6.65. D times 5 feet is equal to 6.65. B is equal to 1.33 tips. Okay. Now, I assumed that D was positive and going in the was creating a positive moment and going in the counterclockwise direction. And I got a positive answer for D. So my assumption was correct. D is going in a counterclockwise direction. So let's see, what does that look like on the diagram here? Well, counterclockwise direction is like this around 0.3. So I think this arrow's got to be going like that. Okay. And if it's like that, if it's going away from joint 2, where that D is touching, then that means that D is in tension. Okay. So now let's think about C. I got B and I got D. I just need C.